Okay, so the example I'm going to give you is some sort of written description of a transformation in a function. I'm going to ask you to write the actual equation and then graph it. So here we have the equation given the parent function f of x equals 1 over x, which is the reciprocal function or the rational function. The function g of x can be created by the following transformations: a reflection over the x-axis, a vertical stretch of a factor of 8, a horizontal translation, a vertical translation down 4 units, and a horizontal translation left 7 units. So first things first, let's write the actual equation itself. Okay, so I know I need to have the form a f of b x minus c plus d. Okay, so there's my generic form. If I knew what a, b, c, and d were, all I do is plug numbers in, and I have my equation. So let's do this. So a, if you remember, a is going to be either my vertical stretch, or my vertical shrink, or my reflection over the x-axis. So it does say it reflects over the x-axis, and if you remember from the notes, that means that my a's got to be a negative number. So my a, I already know is going to be a negative number. Then I'm going to look for the keywords of vertical, either stretch or shrink, or compression. In this case, it does say there is a vertical stretch of a factor of 8. Well, factor of 8, that just means it's my a. So now my a is going to be negative because of the reflection over the x-axis, and the 8 because of the stretch. Okay, so we're going to look for b. What we're looking for b is anything that says horizontal stretch, horizontal shrink or compression, or a reflection over the y-axis. I don't see any of that in here. The only thing I see with horizontal is right here where it says horizontal translation left 7 units. Well, that's a different letter. So I don't have a b. So my b, if I don't have it, I'm going to assume it to be 1. For a or b, if we don't have anything, we assume it to be 1. All right. Now, let's look at my c. My c was my horizontal translations. So I'm going to look. So my c, I have a horizontal translation left. Well, left means negative. And then 7. So my c is going to be negative 7 because I went left. That's negative. And then the 7 is the number they give us. And then last but not least is my d. So my d is my vertical shifts up and down, my vertical translations. Those are the keywords I'm looking for. And I do have vertical translations down. Down means negative 4. So my d would be negative 4. So my actual equation, when I would write this, would look something along the lines of negative 8 f of, well, my b is 1, so I don't have to worry about that, x minus, because that's part of my general form, the minus, my c, a negative 7, and then my d, minus 4. And all I do is clean that up, and we get negative 8 f of x plus 7 minus 4. All right. So right there is my generic equation. Well, what happens if I actually don't want the generic equation? I want the actual equation. Well, that's pretty simple, pretty straightforward. My f of x is 1 over x. So all I want to do is plug everything in. So if I have my f is 1 over x, that means everywhere there's an x, I put this x plus 7, and then these just go on the outside like normal. So I'd have f of x equals, well, if I do negative 8 times this, I'm going to get negative 8. My x, I just put in the x plus 7, and then the minus 4. So this equation and this equation are the exact same thing. Now let's take a look to see how to actually graph this. All right, so we have this, so we're going to go ahead. We have this function, negative 8 f of x plus 7 minus 4, and we are told that my parent function f of x was 1 over x. So here's how we're going to graph this. We're going to set up what's called vector mapping. We're going to do a point-to-point transformation, and then we're just going to plot those points, and we're going to draw a smooth curve. First thing I need to know is, what does the parent function actually look like? Well, my parent function, so we have the equation negative 8 f of x plus 7 minus 4. And we were told our parent function is 1 over x. So what we're going to do is we're going to transform this by doing vector mapping in a point-to-point transformation. But the first thing we need to know is the general shape of my parent function. Well, my parent function, it has a vertical asymptote for the y-axis and a vertical asymptote of the x-axis. And it's going to look something like this. So this is what my parent function is going to look like. This is my launching point. Now I could do all types of different things to it. Now this point right here is 0, 0, which is the origin. That's the intersection of my asymptotes, and I'm actually going to use that to help me graph this. So what we're going to do is we're going to create a table. We're going to list all our parent. We're going to list 6 parent function points, and I'm going to use this point also 0, 0 where the asymptotes intersect. So we'll have a total of 7 points. Then we're going to set up a mapping, and then from there we're just going to plug things in, evaluate. We're going to get our new points, and then we're going to sketch the graph. Okay, so let's take a look. So let's make a table of nothing more than points from my parent function. So I'm going to do -2, -1, -1/2, 0, 1/2, 1, and 2. So -2, -1, -1/2, that's on this side right here. The 0 is the intersection of my asymptotes. It's not actually on the graph, but it's going to help me graph it. And then my 1/2, 1, and 2, they're over here. Now to find the y values, all we do is we plug them back into this. So we do -2. We put -2 in here for the x. We're going to get -1/2. We're going to get -1. This becomes -2 once you just plug them in here and evaluate. Now 0, we already know it's going to be 0 from this. This is my asymptote. You have to remember this is your asymptote. It's not actually on the graph, but it helps us graph it. Now put 1/2 here. We get 2, 1, and 1/2. Okay, so all those are the points from my parent functions and the intersection of the asymptote. Now we're going to set up my vector mapping. This is the key. If you remember, my A and my D affect the y values. So this is going to come over here. It's going to be the y component of my vector mapping. So what I'm going to actually do is, this is -8 times f of x, basically, because this is f of x. So -8 times y minus 4. That's my equation, -8 y minus 4. Easy enough. The trick is, and this is the side that people mess up, is the x. This is the side where most people mess up, is the x. If you remember our original equation, this was f of x minus c. But this says plus, so plus means you have a tendency to go this way. But it was actually a minus a negative. So our equation is actually x minus 7. So you really want to do here the opposite operator that you have. Since we have a plus, we want to do minus because this graph's actually going this way. All right, all we're going to do is plug these numbers in. So I'm going to put -2 in for this x, and I get a -9. Put a -1 here, I get a -8. I put a -4 gives me a -8. All right, there are our x and y components. Now all I have to do is graph it. Okay, so all we have to do now is actually graph this. Here's my points here: -9, 0, -8, 4, -7.5, 12, and on down. So I'm going to draw myself an x and y axis right here. And of course, where they intersect is the origin. I'm going to draw in my asymptotes, which are actually at -7, -4. That's the coordinate of it. So I'm going to go -7, stay right here, -4 down here, and here are my asymptotes. All right, so now we have my asymptotes drawn in. All I need to do is actually graph. So I've got -9, 0. So if this is -7, let's call this -9, 0. -8, -1. Nope, -8, 4. And -7.5 and -12. So that's up in here. So my graph is doing something like this, going through these dots and then coming down like that. And then I've got -6.5. Well, if this is -7, this is -6.5, -20. So that's way down here. -6, -12. Maybe right in here. And then -5, -8. Maybe right in here. So this graph is going something like this. And that's my graph of g of x. Not terribly bad. You don't have to be real precise on your graph. Just kind of sketch it in the right area. Now, if you tell me your asymptotes intersect at -7, -4, and you graph it over here in quadrant 1, then you're wrong. But it's somewhere over here in quadrant 3, it's fine. You can label each point if you want, or if you have the table here with the sketch, that's fine for me as well.